You are about to watch an immersive 360 experience. Look around you to explore many details and enjoy the ride.
Mankind is worried.
According to a new report, experts say that we have until 2030 to avoid catastrophe.
Climate change is a fact.
Right now, we're facing a man-made disaster of global scale.
The biggest climate catastrophe in the world today is air pollution.
Is it right to bring kids into this world with me knowing how bad it's going to be?
Solving this crisis is not a question of politics, it is a question of our own survival.
We need to stop funding things that destroy nature and pay for things that help it.
The universe is in good shape. It's Earth that has all the problems.
We are at a point where we no longer know if Earth can carry us into the future. Preparing for the worst case scenario, humanity is looking for alternative places to live. The search for a new home starts a new space race. An event incompatible with the current climate crisis. Does the search for a potential new home therefore make any sense at all? Many resources would be used up without any guarantee of success. And where could our new home be in deep space? To answer this question, we must first understand what space is and what it can offer us. Space is big and beautiful, but also empty, cold, and dangerous. We live on the unique planet Earth, which is by current knowledge the only celestial body that carries life in our galaxy. We are orbited by the Moon, our closest neighbor in our solar system. We've been there many times before, but the Moon is not around the corner. It takes about 3 days for humans to get there. Once there, we are greeted by an icy cold desert, not a very nice place to live. Gravity alone, or rather the absence of an Earth-like gravity, is already a difficult condition. While we, and especially our bodies, have adapted to a pleasant gravitational acceleration of 9.8 meters per squared second, our Moon offers only 1/6 of it. Jumping on the surface would feel like this. These are conditions that harm our body in the long term. If gravity is too weak or non-existent, people lose bone mass and muscle strength. This counts for our most important muscle too, our heart. Fluid in our body will no longer be dragged down and moves to the upper body and head, which can lead to eye problems and increased risk of kidney stones. But gravity is not the only enemy on the Moon. Cosmic radiation from outer space constantly attacks our body and DNA. Without a thick atmosphere like Earth has, we are only protected by having enough shielding material or by living underground. To make these conditions less harmful to humans, we would possibly make use of genetic modification, since we can't adapt this fast. So why should the Moon even be considered as a candidate? To understand that, we have to look at the bigger picture. Our Moon is the ideal launch pad for further interplanetary or even interstellar journeys. Thanks to the low gravitational pull, rockets need only a fraction of their fuel, not like on Earth where we use most of it. Fuel could also be produced on the Moon, since all components such as hydrogen and carbon are present. But the Moon has more to offer. Helium-3, a rare isotope of helium, at least rare on Earth. On the Moon's surface, there is an excessive amount of helium-3. This isotope is of great importance for medicine in order to detect rare lung diseases, but it could also be used for the energy revolution of the future. Fusion reactors need helium-3 as their fuel. The same does our Sun, which has basically been a giant fusion reactor since its creation. The technology, known as nuclear fusion propulsion, could maybe propel rockets in the future and bring them to even more distant locations in our solar system. But now, let's look at other possible places for humanity to colonize. The next interesting place is our red neighbour, Mars. Unfortunately, he's a little further away. When Mars and Earth are closest to each other, which happens every 26 months, the distance is still about 55 million kilometers. The journey is possible for a human, but it would take 8 to 9 months. This trip is also called the Hohmann transfer. In comparison, light only takes about 3 minutes to reach Mars. The problem is propulsion. We've been using chemical propulsion for a long time now. The system uses liquid oxygen, hydrogen, and classical RP1, which is highly refined kerosene. These give one continuous impulse until all fuel is used. If a new technology, such as ion propulsion, were to be used, the journey could be shortened to less than 20 days. Because ion thrusters are not only more ecological and use xenon as fuel, but can also accelerate the spaceship multiple times up to a speed of 150,000 kilometers an hour. Arrived on Mars, we are greeted by a much more pleasant gravitational force, which is about a third of the Earth's. Compared to the Moon, the physical damage would not be nearly as fatal. It is even assumed that the body could adapt to this gravity. So is Mars the ideal planet for our second home? After all, there is water in the form of ice here, and with a little extra help, you could also use the soil as a basis for plants and food. But like on the Moon, the lack of oxygen to breathe in the atmosphere forces us to build an enclosed base here as well. Additionally, we must shield against cosmic rays. Alternatively, we could use the underground cave systems of lava tubes. Down there, we would be protected from strong temperature fluctuations as well as sandstorms. Although the sandstorms on Mars are not as strong as on Earth due to its less dense atmosphere, the fine Mars dust is a danger to humans as it could easily be inhaled by our lungs. Even if we were to get that far, there would be another problem. In the worst case scenario, sending a message to Earth takes 20 minutes, plus another 20 minutes before you get an answer. You might say 40 minutes isn't that much, but if there's a life-threatening problem, the people on Mars would be completely on their own. Unless we could find a way to send information from Earth to Mars instantly, quantum entanglement, a theory of quantum mechanics, could prove to be the solution which enables real-time communication. But very little is known as of yet, so let's go on. Nevertheless, life on Mars would be possible, and we are getting closer and closer to the possibility of the first manned flights to Mars by 2030. As we leave Mars for now, we can take a look at our third candidate. He is positioned in orbit around Saturn. However, the distance is so huge that we need a new unit of measuring. One astronomical unit describes the distance from Sun to Earth. Mars is about half an astronomical unit away from Earth, but the place we're looking for is about 8.5 astronomical units away from Earth. If we were able to travel this distance, we would meet him here. Saturn's moon, Titan. Titan is not as big as Mars, but bigger than our moon. Compared to our moon, it rotates slower, causing the gravity to be even weaker. Why then is Titan so exciting? It's his atmosphere, because he has one that is even 4.5 times denser than the one on Earth. This helps the climate maintain the temperature on the dark side as well. With approximately -180 degrees Celsius, it is cold nonetheless, and you can't breathe either. We assume that there are lakes and rain on Titan, however, raining methane instead of water. The surface protected from cosmic rays consists of rock and ice, We know this thanks to Huygens, a probe from the satellite Cassini, which was able to land on Titan and take these pictures. As science suspects, Titan could be in a pre-Earth state, where the greenhouse effect could perhaps someday lead to development of life. Whether us humans could find a home there is still uncertain, since we simply don't know enough about Titan. We now know our candidates in our solar system and the effort it takes to get there, but we should still ask ourselves if it is really worth it. Many argue that we should rather invest our resources in saving Earth. Space exploration costs a lot of money and time from brilliant minds. So far, the International Space Station ISS has cost $150 billion. NASA has an annual budget of about $22 billion. And bringing a 1-ton satellite into Earth's orbit carries a $20,000 price tag. Only by the commercial interest of private space companies like Blue Origin, Rocket Lab, or SpaceX were we able to reduce the costs through mass production and reusability. Now the same 1-ton satellite costs only about $5,000. This drastic change in space economy could lead humanity on a different path of expansion. There are many concepts of large space stations for humans to live in. Thanks to rotating parts, we could generate an artificial gravity similar to Earth. Putting people up to space is something we already have achieved, and where we gained a lot of knowledge. But legitimate voices also criticize the neglect of space debris. It seems nobody wants to take responsibility for our space junk in Earth's orbit. Should we therefore regulate, restrict, or even forbid space travel at an international level? Though in reality, a world without satellites would not be possible. Many technologies, such as GPS, weather forecasts, and natural disaster prevention, depend on it. We benefit from milestones in science, medicine, but also in everyday life, thanks to space research. A restriction would also have a massively negative effect on technological innovation. It is unclear whether we would harm ourselves even more with such actions. Stephen Hawking predicted before his death that humanity has only 100 years left on Earth, before we destroyed it through our own actions, and with it, us as a species. Believing his statement, a new place to stay in our galaxy might be the last hope to survive. But Earth is not over yet. It may not look great, but we still have time to make changes. A change in our thinking and taking action is needed. We can't just throw such a paradise, a remarkable creation of a life-bearing planet, away. But we may need some help with new technologies and tools. Things we would invent and develop faster with the help of aerospace companies and their research. The CEO of one of the leading private space companies, SpaceX, says that 99% of all resources should be invested in saving our planet. The final 1%, however, should be invested in space travel and research to broaden humanity's horizon. The importance of this 1% should not be underestimated. What's certain is that nobody wants to lose this magnificent view of our home, our Earth, something truly worth fighting for. What do you think?